Hi there, everyone. Welcome to another Sci-Fi Dragon presentation. I'm posting this video as a companion piece to my Jupiter 2 Revisited video. This is a repost of my Lost in Space B9 robot build. It just seemed right to post this video to go along with the Jupiter 2 video, since B9 was such an essential character in the original Lost in Space TV show. What follows is the complete original footage of the B9 build video, including the original opening and end credits. Other than adding these B9 still photos, the only thing I've changed for this presentation is the background music. One last note. The original end credits include an invitation to visit the sci-fi-dragon.net website. I shut down the website on February 8, 2023, and it will soon become totally inaccessible sometime in March. So please just ignore the invitation in the end credits. Alright then, here's my complete original B9 robot build. Enjoy!
Hello folks, in this video I'm going to go through a build-up of a 1/6 scale model of the B9 robot from Lost in Space. Instead of using expensive commercially produced electronics for B9's lighting systems and sound effects, I'm going to be improvising my own using chaser boards and a soundboard that I got from a broken B9 model that I had years ago. At various points during this video, I'm going to insert still photo slideshows to illustrate some of the construction procedures. If you need to get a longer look at any individual photo, just use your viewer's pause button. One last comment before I begin building my B9. When building any plastic kit, it's always a good idea to read through the instructions before you start working on the model. Take particular note of any painting instructions and how the key parts of the model fit together. For a project like this, where you'll be adding LED lighting and wiring to the model, it's imperative that you go through the instructions and examine all the plastic parts so you'll have some idea of what you'll be working with before you start. I suggest viewing this video completely before you begin and viewing the 5-part Dr. Faust video also. Between these two videos you should get a good idea of what planning and extra steps you'll need to take to build a B9 kit with the added lighting and sound features. Remember, above all, be guided by your own level of experience and the tools and materials you're used to working with. The first part of B9 I'm going to work on is his brain, or the brain case. My first step was to modify the 3 side panels, that's these parts, to let light pass through them after they've been painted. To do that, I used this number 62 wire drill bit, and I used each one of the little hieroglyphic characters on there as a alignment point and just drilled out each one of the hieroglyphics. Now, it's not going to leave B9 looking exactly like he should, but it's going to give me a nice, clean, bright light feature on that brain case. A standard 5mm LED like the one I'm holding is far too big to fit between the top and bottom plates of the brain case. After a bit of hunting around my favorite electronics supplies websites, I found the perfect LEDs for this job. These little Shenzhen 2mm LEDs are flat and square and take up hardly any space at all. This is what I'm going to use to light up B9's brain. To make it easier to space out the LEDs and solder them together without damaging the plastic base of the brain case, I traced that base part onto a piece of cardboard. The LEDs will be positioned on the cardboard, taped in place, then soldered together to form two groups. I'll have 3 LEDs facing the front of the brain, and I'll have 2 LEDs, one facing each side of the brain. Each group will then be wired so that they light up and flash independently of the other group. Here's one of those points where it's very important to have looked over your instructions and checked out your kit parts. As you can see, the bottom of B9's brain box has no hole in it for you to pass wiring through. Take a quick look at the kit instructions, step 1D and 1E. You'll see that the brain case rests on a small collar that holds the sensor stalks. Unless you don't care that the wires from your brain can be seen, the only way to hide them is to run them through this part. Because the front of this collar is going to have to be drilled out to hold fiber optic strands, the hole for the wires from the brain is going to have to be drilled at the back. The next thing to do is place the clear bottom part of the brain case on top of the sensor collar and mark off the spot where that hole is on the sensor collar. I'm going to use the point of my X-Acto knife to open this hole up just a tiny little bit and clean away any rough spots that were left behind by the drilling. As my next step, I assembled the sides and bottom of the brain box and painted the entire brain box flat black on the outside to keep light from leaking through when I install the LEDs. Following the kit instructions, I painted the top of the brain case bright aluminum, or shiny aluminum as they call it. The main portion of the brain case, meaning the bottom and the 3 sides, have been airbrushed with Tamiya metallic gray. Once I cleaned out all the holes in the 3 sides of the brain case, I installed B9's eyes. The next thing to do is to add the small light bulb parts to the top plate of the brain case. All I have to do to complete the brain case at this point is install the LEDs and attach the top plate. There's the completed brain case. Now I'm just going to take a moment to test the lighting and see what it looks like. That's the light from the LEDs in the rear, the ones aimed at the side panels. And there's the lighting for the front panel. I want to try to light up these finger lights. To do that, I'm going to have to run fiber optic cable through the mounting collar that you see here on the right. To connect the fiber optic cable to the finger lights, I'm going to use pieces of 1/16 inch diameter plastruck tubing. Here I have one of my pieces of 1/16 inch diameter plastruck tube. As you can see, I cut it to the same length as the shaft on the finger light. Here's the base that's going to hold the finger lights. I've drilled out the holes in the front to 1/16 of an inch to accommodate the plastruck tubing that's going to have to fit in there. The assembly sequence for this part goes something like this. First, cut the stem of one of your finger lights down to about 3/8 of an inch in length. Okay. To avoid fogging the plastic at the back of the finger light, I'm applying a small drop of jeweler's cement, which won't affect the plastic at all. And I'm inserting that in the front end of my new stalk. Once the finger light is attached to its new stem, the fiber optic cable can be slipped in the back. Okay, I've installed all the finger lights in the bottom half of the collar. You can see the fiber optic cable sticking out the back. I just have to put the top half of the collar in place and paint it, and then I can mount the brain case to it. The next step is to install B9's brain into the bubble housing. Once the brain is inside the bubble housing, you have to attach this connecting shaft to link the brain assembly and bubble to the radar assembly that sits underneath it. The problem is that this is the connecting shaft, part number 53. It's pretty much solid once you put the two halves of it together, and there's absolutely no room there to pass your wires and fiber optics through. Here I have two pieces of plastruck tubing. They happen to fit into each other, like so. And the larger one fits into the robot's neck. Here you can see the two pieces of plastruck tubing cut down to size. B9's neck is made out of a vinyl-like material. This vinyl material does not react at all well to cyanoacrylate cements. I can't use plastic welder to attach parts to these vinyl pieces because that would probably melt the vinyl. So, to attach the support piece inside the neck, I could use jeweler's cement, which is totally non-corrosive and which shouldn't damage B9's neck at all. Or I can use this other adhesive, which is Loctite's Stick and Seal. Here you go. And that is also non-corrosive, and it should connect the two parts safely and securely. We'll see. The only drawback to using the Stick and Seal is that this is going to have to sit for at least 2 hours for that cement to set up and harden. Here I have the bottom half of the bubble casing for B9's brain, and here is the neck support part. As you can see, the hole in the bottom of the bubble housing is not quite big enough to fit this piece of plastic. So the first thing I have to do is very carefully drill or shave that out. Here you can see the brain and the bottom of the bubble housing with the support piece in place. This is only a test fit, nothing's been glued together yet. This will be another good place to use the Loctite or the jeweler's cement so that they don't craze or damage the clear parts of the bubble. Building this part of B9 is straightforward. The only modification needed here is that the hole for the support strut coming from B9's head has to be enlarged. Other than that, I just have to follow the kit instructions. way I connected these parts using this central shaft coming down from B9's brain, this whole part here can rotate. In fact, his head can rotate and the ears can rotate separately. Okay, I should have mentioned this earlier, but I forgot. The shaft that I use to connect B9's brain with the rest of this assembly is plastruct tubing that is 1/4 of an inch diameter, and I cut a piece about 1.5 inches long so that it would stick all the way through down to just about inside the body. To keep this from slipping up, I'm going to glue on this ring that is made out of plastruct tubing. This is 3/8 inch diameter, and I cut it about 1/8 of an inch wide. Just a drop of plastic welder will keep that locking ring in place. I've laid out the main parts of the body, and I'm going to pre-paint them on the outside with flat aluminum as indicated in the kit instructions. The nice thing about this kit is that there's a lot of room inside B9's body for installing electronics. However, I plan on installing a soundboard, which of course means installing a speaker, and 2 separate chaser boards to drive the various lighting elements in B9. I've airbrushed B9's body using Tamiya's flat aluminum, and to further dull the paint and give it a nice soft patina, I oversprayed that with dull coat. According to the kit instructions, this front panel and the 2 armpits are supposed to be sprayed metallic gray. Now, I think that's fine for the front panel, but I think it's going to be a little too dark for these panels. So what I'm going to do is I'll spray this metallic gray, then I'll thin that out with some flat aluminum to give it a little bit more brightness, and then I'll spray those 2 parts. While I was painting B9, I was thinking about how to install the speaker and those 2 chaser boards and a soundboard inside without ending up with a jumbled mess. The solution I came up with is actually pretty simple. I'm going to use these little pieces of plastic that I cut and these steel rods. I know it looks like plastic. It's plastic on the outside and steel on the inside. And I'm going to build a little shelf assembly and simply stack the electronics up one on top of the other. Because the steel rods are coated in plastic, I can use my ordinary plastic welder to glue them in place on the bottom part of the shelving assembly. I don't need to do anything fancy here. For the bottom plate on this shelving set, I used a piece of 080 styrene because that's thick enough to hold the posts. I have my posts in place, and now I'm just going to test fit the speaker I want to use. Fits very nicely. And I have room over here for the soundboard. I'm cutting some plastruct tubing into 3/8 inch long pieces, and I'm going to use those as spacers to keep the first circuit board from sitting directly on top of the speaker, because that would block the sound output. Okay. So, thanks to my handy dandy measuring device, I have now got 4 pieces of spacer that are all the same size. There we go. Now, I don't need a lot of space above the speaker, just enough to keep this circuit board from blocking it off. So test fit the circuit board, see if it's sitting okay. It just has to go onto the rails, the rods. There we go. And I have plenty of room. There's roughly 1/4 of an inch separation between the speaker and the circuit board, and that should be more than enough to let the sound out. The second set of spacers is holding up this shelf here, and that shelf will hold my second chaser board. Now you may be wondering why I'm using 2 different chaser boards. This one down here on the bottom allows me to select between different randomized lighting patterns. This little one, however, lets me do the same thing, but it also lets me control the speed at which the LEDs chase each other. I think that is going to be much better for controlling the LEDs that go here on the front of B9's body, while this simpler one here on the bottom will control the LEDs in B9's head and the finger lights, if I can get them to work. Okay, I've finished soldering together the chaser board that I'm going to use to power the LEDs in B9's chest. I'll just do a quick check to make sure that I didn't mess up anything when I soldered this together. And will you look at that? It works. Let me show you why I like this particular chaser board. Right now the LEDs are flashing and chasing around far too fast for the effect I want to have when I put the LEDs in B9. So I can come over here to this potentiometer and I can just turn this until I get a speed that I think I might like. Now, once I actually install the LEDs in B9's chest and connect them to this chaser board, I can go back and I can either make them flash a little faster or a little slower. The next piece of prep work I'm going to tackle is building a set of connectors to link the fiber optic cable from the finger lights to the LEDs that are hopefully going to light them up. To hold the LEDs, I have a piece of tubing that's just a little over 3 millimeters in diameter, which is perfect because the LEDs fit right in there. That 4 millimeter opening is clearly too large to hold a fiber optic strand. So I'm going to reduce the size of the opening by inserting this smaller piece of plastrut tubing. I'm not sure what the diameter is on that, but it fits snugly into this 4 millimeter piece. And then, since that's still a little too big, I'm going to insert a piece of this 1/16 inch tubing in there. And that's the same tubing that I used to connect the fiber optics to the back end of each finger light below B9's head. And the fiber optic cable will fit very nicely right in there, and it'll be held directly above the LED, and hopefully that'll give me a nice bright light output back up at the finger lights. If it works, great. If it doesn't, I'm not going to cry about it. Those finger lights are just such a small detail that I'm not going to get upset if this doesn't work. But I'm going to give it a shot. Okay, I've cut 7 pieces of the larger size tubing to just a little bit over half an inch in length. Now I'm cutting down the middle sized piece of tubing to exactly half an inch in length. The extra length on the large tubing is to accommodate the length of the LED that has to go inside. So I'll get all this stuff cut, and I'll cut 7 pieces of the 1/16 inch tubing to half an inch, and then I'll be ready to start putting the stuff together. Before I solder the wires to the LEDs here, I'm going to glue together the plastic tubes holding the LEDs so that I have a cluster or a bundle. Hopefully this will keep the fiber optic strands and the wires from these LEDs a little bit neater so that they don't go flopping all over the place inside B9's body. And okay, I've attached the LEDs that are going to power B9's brain to the chaser board, and I'm just running a real quick test here. It looks like everything works fine, and now I can move on to the next bit of prep work. Now it's time to tackle the soundboard that will provide B9's voice. Out of this whole big tangle of wires, all I really need is one pair to drive an LED inside of B9's mouth, and the wires that lead to the switch that turns the voice on. Okay, I've simplified all the wiring on B9's soundboard, and if I did it right, he should be able to speak, and this LED over here should light up his mouth. Let's take a look and find out if I did this right or if I screwed it up. Looks like it works. Okay, so now I'm ready to start building my little stack of circuit boards that I can put inside B9's body, and then I can start working on the lighting arrangement for his chest. Okay, here we have the completed electronics tower that's going to provide all the LED lighting effects for B9. Down on the bottom I have my soundboard. In the center is the chaser to drive B9's head lighting, and on top is the other chaser board which will control the lighting in B9's chest. While I was completing the circuit board package, I decided to make one small change to the lighting in B9's head. I'm going to add these 2 yellow LEDs to light up B9's neck ring. The next part of B9 that I'm going to work on is the lighting panel for his chest. I want to light the upper portion of the panel, the square lighting area, with an LED that burns steady, no blinking, no flashing. To light up the upper area where the square parts are, I created this little light box. It's made out of a piece of Plastruct U-channel, and I installed 2 flat 2mm LEDs in there. I've come up with a real simple way to soften and diffuse the light coming from that light box, because it is a little too bright. I'm very simply going to cover the back of this part with a couple of layers of frosted Scotch tape. That ought to take the light down just a little bit and ought to smoothen it out a little so that I don't end up with any hot spots. Since I don't want these LEDs to blink, I'm not going to attach them to either one of the 2 chaser boards inside B9. I'll have to attach these directly to the DC power source, which is going to be approximately 7.6 volts. The problem is these LEDs are made to be powered by no more than about 4.5 volts. To prevent my 7.6 volt input power from burning out those two LEDs the minute I turn them on, I've linked together two resistors. One is 220 ohms, the other is 120 ohms, for a total of 340 ohms of resistance. I will attach that to the positive lead, and that will provide enough buffering to keep the current from burning out the LEDs. The next thing to deal with are the round lights that go at the bottom of B9's chest plate. And there are two ways to deal with this, I think. I could just clip all these off, drill them out, and put the LEDs through this part. However, that presents a small problem. Since this is clear plastic, it's going to transmit the light from any one LED when it's, to every other LED on the panel. So I'm going to do this the easy way. I'm going to cut off this bottom part of B9's chest plate clear part, and I'm going to install my LEDs directly into B9's chest, like so, I hope. Again, this is a good place for using either the stick and seal or the jeweler's cement that I've been using, since it won't have any effect on the plastic housing of the LED. I've painted the clear parts for the square lights on B9's chest. While this paint dries, I'll do a little work preparing to install the white LEDs that go directly above those square lights. If I insert one of these white LEDs directly into B9's chest, it sticks out way too far. The solution to having those LEDs stick out too far is actually kind of simple. It's just a block of styrene plastic built up to an adequate thickness to pull the LED back away from the opening. The next part of B9 I'm going to work on is his mouth. Now, to create the mouth, you are supposed to attach these clear parts to this gray plastic frame. Now, the problem this presents is that it's going to be almost impossible to put enough light through that gray plastic to light up B9's mouth adequately. The solution that I've come up with to this little problem is to frame out the underside of the gray part using 1/4 inch Plastruct U-channel. After I frame it out, I'll cut out the center area and replace that with a piece of frosted film, plastic film. Okay, I've completed the assembly for B9's mouth, or voice box, or whatever you want to call it. And if I turn this around, you can see that I'll be lighting him up with 3 very bright red LEDs. I'm still going to end up with some hot spots, but it doesn't look bad. You'll see a bright spot there and a bright spot there and a bright spot here just slightly off center, and when he speaks, that whole mouth area should light up very nice and bright. The next thing I'm going to work on is the bottom part of B9's body. I've already attached the mounting collar here at the bottom, and I've installed B9's tape recording unit with the sliding cover, and the only thing I did to that was add a yellow LED just to give it a little more punch. There we go. And that'll blink on and off once everything's wired up. Before I install the clear panels in the side ports, I'm going to drill a couple of holes in the bottom of this part so that I can run the power lines from my circuit boards down through B9's legs and out to the display base that he's going to stand on. Okay, here's the bottom of B9's body, and I've drilled 2 pilot holes for where I want to run the power supply wires from my circuit boards down through B9's legs. This is the plate that connects B9's body to the top of B9's legs, and the wires from the circuit boards are going to have to pass through this plate also. So I've drilled matching holes in this plate. I have holes drilled to pass my wires through both the bottom part of B9's body and the connector plate that attaches to his legs. B9's body is supposed to swivel on top of the leg plate, but that presents a small problem. If I put my wires through those holes, he's not going to be able to move. The first thing I'm going to do is make these holes a bit larger so that I will be able to pass all the wires through them without crowding anything. And the next thing I'm going to do is enlarge these and connect the 2 of them with a slot that I'll open up here so that the wires can move back and forth between those 2 holes, hopefully. Okay, I finished cutting this arc into the connection part of B9's body, and if I put this piece in place, and I checked it out, and it looks like I get about maybe an inch worth of movement in either direction, and that's more than enough if it works. I need to airbrush this part, with the flat aluminum to give it the proper finish, but I'm going to put that aside and skip forward here and start assembling B9's feet and legs. That way I can spray paint this part and the feet and get all that done at one time. Okay, I have finished spray painting the flat aluminum finish on the part that connects B9's body to his legs. So I put that aside, and I've finished assembling B9's feet. Given them a preliminary coat of flat aluminum paint. which I may leave a little on the rough side because, let's face it, he's been banging around in space for a while in all kinds of terrain, so maybe his paint job ain't quite perfect anymore. But on a more important note, at the top of each foot assembly and at the bottom of each foot assembly, I have cut out these large square or rectangular areas so that it'll be easy to pass the wires through from his body and down to the display base where the power supply is going to come in. So that much is done. I'm going to skip back to working on his body at this point, and I'm going to install the clear parts, his side panels here. The third opening which is here at the back of B9's body, is supposed to also have one of these clear panels installed in it. However, the speaker for B9's voice is going to sit practically in front of that opening, so I am not installing the clear panel back there. That would muffle the sound coming out of the speaker. To help get the sound out a little bit more clearly, all I'm going to do to cover that hole is install one of those photo-etched metal pieces that comes with the kit that looks like wire mesh. So that should cover the hole nicely, and it should allow me a better quality of sound, hopefully. Certainly it'll be better than having the body completely closed in when it's finished. I'm just about ready to start connecting the chaser boards to the LEDs in the front of B9's body. Before I do that, however, I have to convert this switch mechanism so that I can trigger the vocal effects for B9. Instead of running more wires down through B9's legs and into the display base and putting buttons on the display base to trigger B9's voice, I'm going to use two of these magnetic reed switches. I've cut two sets of notches in B9's back plate. One here and one here. I'll rest the reed switches in those notches, and by placing a magnet outside B9 right behind there, I should be able to turn on his voice circuit. Here are my two magnetic reed switches. I installed them by cutting a notch into each of these two rim pieces here, and just sliding the wires into the notch and covering them over with these little pieces of plastic to hold them in place. I also attached some wire leads to make it easier to connect this to the soundboard later, because this will be the last piece put in place. So it might be difficult to try and solder the connections at the bottom. Alright, with those in place, I can move on and start the really fun job of installing all of this. Wish me luck. At this point, I've completed B9's main body, and I've attached it to the part that connects him to his legs. This slot seems to be working out pretty well. I've actually got a good range of mobility there. We'll see what happens after I run these wires through the legs. Here's what the inside ends up looking like if you're going to improvise your own electronics. It's a little bit messy. Well, it's certainly messier than if you were using integrated circuit boards, but it all works. Right now these fiber optic strands are far too long, so I'm just going to get an idea of how they'll fit into the holders and mark off how much I need of the fiber optic cable with this little piece of heat shrink tubing, and then I will cut down the fiber optics to the length I need. The next step here is to take some of these little plastic tubes I cut and attach them to the end of each fiber optic strand so that they will fit snugly into the LED adapters. Okay, a quick test of B9's headlighting. Well, his brain case seems to light up okay, and in fact the eye stalks are lighting up, but they're so dim that you can't even see it. I'm pretty sure that it's not even going to register on camera. It really didn't work out at all the way I'd hoped, but it was worth an effort. You know, it was worth trying. So I'm going to go back and simplify B9's insides before I close them up. I'm going to remove all that fiber optic cable. It's just taking up space and doing nothing. Aside from running the electrical wires down through his legs, building the rest of B9 is just a matter of following the kit instructions. Just remember to use a non-corrosive adhesive when you're joining these vinyl parts to the plastic parts. You don't want to damage them. Well, B9 is finally completed. I finished the display base in pink sand and some crazy looking plants to try and capture the feel of some of the very strange planets that B9 ended up having to visit. Usually I would have installed a toggle switch either here on the front or maybe over here on the side to activate the lighting features in B9. However, since I found my supply of magnetic reed switches, I thought it would be interesting to see if I could create a display base that wasn't, disrupted by the presence of a switch sticking out of it. So all I have to do to activate B9 is take a small magnet, place it right there on the front, and there he goes. One thing that actually worked out better than I expected is the fact that I can rotate B9's body. The wiring that I ran down through his legs doesn't seem to interfere with that at all. And of course his hands are movable. His claws open and close. Well, that's my B9 build-up. He's not perfect, but I'm rather happy with the way he turned out. So that's it for this video. I hope you enjoyed it. Thanks for watching, folks.